Onward and upward, and today we have geometric series. We're going to add up geometric sequences. Remember, I talked to you about a series is when you take a sequence and put plus signs in between it. And then you just add it all up. But we can't use Gauss's little trick here. If we tried Gauss's trick, 2 plus 64 would be 66, and 4 plus 32 would be 36. So Gauss's trick only works in arithmetic sequences. And this is a geometric, as we can tell, because we're in the geometric. Multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. Here is another formula that, yes, you have to memorize. Like my little snowman in the back? Cute. All right, this is the sum of a series. S stands for sum. The N stands for a certain number of terms. They could ask us to add up the first 12 or the first 5. And as usual, take the first term, a sub 1, and multiply it by 1 minus r to the n over 1 minus r. Now, I could go into a mathematical proof of this and bore the living daylights out of you, or you could just submit it to memory. Okay, let's get right into the examples. Example 1, they want me to find the first 10 terms and then add them up. I could do the old-fashioned way. I could say 2 plus 1 plus a half. Let me find out what they are getting multiplied by. What did I multiply 2 by to get to 1? A half. What did I multiply 1 by to get to a half? A half. So if I kept doing that out, kept multiplying everybody by a half, and finally I'm at my end here. But oh my goodness, then I'd have to put that in a calculator and add it up. That takes too much time. So let's do our geometric formula. To sum up any amount of terms, we take the first term, multiply it by 1 minus r to the n, divide by 1 minus r. Alright, so let's do this. I'm taking the sum of the first 10 terms. So I take the first term, which is 2, 1 minus, remember r is my common ratio, which I figured out to be 1/2, to the n power, because I'm doing 10 terms, and then I divide that by 1 minus r, which is a half. Alright, 1/2 to the 10th power. Well, I'm going to have to get out my calculator. Okay, there's my calculator. Turn on, clear out the other stuff. Let's see, I have to do 1/2 to the 10th power, so 0.5. Well, you know what? I can actually just type this all into the calculator. Why am I making this hard? 2 times parentheses 1 minus 0.5, raise that to the 10th power and parentheses. So that's what my numerator is. I'm going to divide that by parentheses 1 minus 0.5. A dirty decimal. Let's go into our math key. Let's convert it to a fraction. Ah, there's my answer. 1023 over 256. Now, if you didn't want to memorize this formula, you could have always used the sum of the sequence. Remember, I could have gone into second function, stat, gone over to operations, go over to math first. I want to sum up, then go back into stats, go into operations, find sequence, choice 5, But then I have to figure out what the equation is for the sequence. And, all right, let's do that. A geometric sequence is found by taking the first term, which is 2, and multiplying it by r, which was 0.5, and raising it to the n minus 1, because here we don't know how many terms we want. We just want to look at them all. So that's what I would have to type in over here. 2 times 0.5 to the, in parentheses, x minus 1, comma, define the variable as x, comma, and I want to go from the first, comma, to the 10th. And double set of parentheses, and voila, there's my answer again. Same answer. So you've got your choice. Potato, potato. Either memorize the sum of a geometric formula, or understand that you're going to have to figure out the explicit geometric equation and then put it into your calculator. We'll get to that other one in a minute. Okay, example 2. Find the sum of the first 5 terms of a geometric sequence whose first term is 2 and whose fifth term is 162. Oh, everybody want to say hello to my little dog? Hello, Fenway, say hello. Who's here? Okay, she'll start crying. Okay, moving on. Oh, that should be a question for your video quiz. What's my dog's name? Fenway. Okay, anyway, moving on. Find the sum of the first 5 terms. So I've got to find out what the first 5 terms are, and there's my little cheat sheet. All right, my first term is 2, and my last term is 162. I know my formula for the sum of a geometric series is as such. I need to know the sum, let me do a different color there. The sum of the first 5 terms is the first term multiplied by 1 minus, oh, I don't know what my r is, so I'm going to have to figure out what my r is. All right, up here. 2 got multiplied by 1, 2, 3, 4 r's. And that got me 162. All right, divide by 2. 4 r's is really r to the 4th, so that is 81. And now I have to take the 4th root of 81. And the 4th root is a quick way to do the 4th root is, remember, you take the square root twice. So the square root of 81 is 9, and the square root of 9 is 3. All right, so after all that, I figured out r was 3. Finally, I can go back to the problem down here, stick a 3 in for r, a 5 in for n, and a 1 minus 3 down here. Let's see, 3 to the 5th. Well, 3 to the 4th is 81, it's 243, so it's 2 times 1 minus 243, so negative 242 all over negative 2. Well, negatives cancel out, so that makes that positive. 2's cancel out, so hey, the sum of the first 5 geometric sequence is 242. And the same way, if you don't want to memorize the formula, you could take the time to write out the explicit formula. The explicit formula is found by taking the first term and multiplying it by r to the n minus 1. Okay, my first term is 2. We figured out my r was 3 to the n minus 1. All right, bring out my calculator, and I can do the same thing again. Second function stat, let's take the sum of this sequence, which is 2 times 3 to the x minus 1, comma, define the variable as x, comma, and I want to go from 1 to the 5th term, and there's my answer, 242. All right. If right now you'd like to, this is the last slide in the video, so stop this, write this down. These are all the formulas you're going to have memorized for the test. Allow me to say that again. Memorized for the test. Bye.